Hello everyone, this is Vardhaman. This is the very first video of our course. This will be mostly theoretical. This will help us to build a basic understanding of the course. So for this video, you have to bear with me and follow along. From the next video, things will get interesting as we will start learning practical concepts. Now let's begin the very first topic of our course, that is algorithm. It is a combination of sequence of finite steps to solve a problem. To better understand, let's take a real world example. If you want to cook a dish, then we can get the recipe from the recipe book and we will follow the steps in the book and we can cook a dish easily. So here the ingredients like vegetable, oil, spices, these are input, and the set of steps written in the recipe book is algorithm, and the finished dish that we will get is the output. So to summarize, we have a given input which is then converted into finished output by following certain set of steps, and those set of steps combined is called an algorithm. Now let's discuss some property of algorithm. The first one is an algorithm should terminate after finite time. It should not have any infinite loop and it should not run forever. It should finish within a certain amount of time. Second is it should produce at least one output, as an algorithm without any output is useless, and an algorithm can have 0 or more input. For that, let's take an example of random number generator. It do not take any input but it produces a random number as an output. Third one is every step in the algorithm should be effective. It should not have any repetition or redundant code. We can take an example x equal to x into 1. So this is x itself, so this code does not have any significance, so this code is redundant. Fourth one is an algorithm should be deterministic. This means that the output should not change for same input. Last one is it is independent of programming language. Once the algorithm is designed, then it should be flexible enough to be implemented in any programming language. Now let's see what are the steps required to design a particular algorithm. So there are a total of 6 steps. First is problem definition. You should know the problem and what the actual ask is. Second is design algorithm. After understanding the problem, you should design a solution to that problem. Third is drawing a flowchart. Here we represent all the steps that are written during the design of the algorithm in the form of a flowchart. Fourth point is verification. So we will verify the algorithm for different input and check if we are getting the required output. Next point is coding. So after all the verification is done, we can start coding the algorithm. Last is analysis of algorithm. Here in this step, space and time complexity of algorithm is calculated. This is the most useful step for our course and we will be analyzing the algorithm throughout the course. Now let's look at analysis of algorithm in detail. Analysis of algorithm help us to understand how much resource our algorithm is taking in terms of CPU and memory uses. For a given problem, there can be many different possible solutions, but the best possible solution is determined by two factors. First is time complexity. This is the total CPU time taken by an algorithm to compile and execute. Second is space complexity. This is the main memory utilized during the execution of an algorithm. More priority is given to time complexity. In any case, to solve a given problem, if the time complexity of two algorithms is same, then we consider space complexity as a tiebreaker. The algorithm consuming less memory will be selected. We will discuss time complexity in detail. So time complexity is the sum of compile time and run time. Compile time is dependent on compiler, which is a software dependency, and runtime is dependent on type of processor, which is a hardware dependency. Last topic is types of analysis. So there are two types of analysis, a posteriori analysis and a priori analysis. We will be talking about few difference between them. First point in a posteriori analysis, it depends on the language of the compiler and the type of processor. Good processor is faster than a slower processor. Similarly, some language compiler is faster than the other. So it is completely dependent on the hardware which is the processor, and software, which is compiler. In a priori analysis, it is independent of language of compiler and the type of processor. Second point, in posteriori analysis, it gives exact answer. It is calculated after the execution of a program, so the value we get is generally in milli or microsecond. In case of a priori analysis, it gives an approximate answer. It is manually calculated and no processor or compiler is involved, so it can be calculated even before the execution of program. In posteriori analysis, we get the answer like 0.1 microsecond or 0.2 millisecond, but in a priori analysis we get the answer in terms of notation, which is big O of n or big O of n square. Third point, in posteriori analysis, the answer will be different for different computer. Posteriori analysis is dependent on hardware and software, so the answer will change based on the type of software and hardware provided. In a priori analysis, answer will not change. It will remain same on every computer, as there is no dependency of hardware and software. It is pure manual effort, so answer will always be same.